It's something that I think we can go through in the last 5 minutes pretty easily. Thus far, we've only considered ideal sources. We did talk about physical sources back in electronic systems, but so far in linear graph theory, we've only talked about ideal across and through variable sources with no regard for consideration of the power limits available to real-world sources. Consider the following. A voltage source provides a prescribed voltage to a circuit. The current supplied depends on the circuit itself. Let's consider a simple resistor circuit. So we've got this. Now let's say that the source voltage is 5 volts. Then the current going through it is going to be 5 volts divided by R. Okay? Now if we make R, if we drive R to 0, then this is going to go to infinity, right? What? Infinite current. That's right. Can't do that, right? Power to infinity, but of course it's impossible. Real physical sources can't provide infinite power. For this reason, we use one of the following source models when we want to guarantee that nothing too unphysical will occur in our model. You don't always use these. It's sort of an interpretation based on the problem that you have. Sometimes you're going to stay within the ranges of your voltage source at all times, and it will be essentially an ideal source, and you can treat it that way. So a Thevenin equivalent and a Norton equivalent are the two types that we'll do, just like before, but now we can draw them like linear graphs, which is very similar to the circuit diagrams, right? These equivalent sources have exactly the same input-output characteristics. They're expressed in the following forms. So the across variable is equal to Vs minus R times F. So generalize across, generalize through. So what this is just a straight line from Vs to Fs on the VF curve. So you can't, if you want to have a lot of across variable, you have to give up some of your through variable. If you want a lot of through variable, you have to give up some of your across variable. That's how real sources work. A lot of them actually work something more like this. I'm just going to draw this in and erase it, but actually works something more like this. But that's not linear. It's harder to work with, so we don't use that very often. We can though. We can do that if we really want to be good.